Good morning. My name's Gavin Gray. I'm going to be moderating the Changing Landscape of Safety session. So if you're not in the right session, you can bow out and go to a different session. But one of the things that I just wanted to cover some of the ground rules that we're going to be using for this session. If you do have questions, I'd ask that you type them in the Q&A pod. We will try to answer as many of those questions live as we can after each individual's presentation. And there'll probably be a little time at the end as well that we can try to answer some more questions if you have general questions. But if you'd use the chat feature or the Q&A pod, we'll try to get those questions answered as best we can with the time allotted. So while our first presenter's loading up their presentation, I just wanted to talk a little bit about the changing landscape of safety. I've been in the position at PennDOT as the chief of the highway safety section for almost 6 years now, and a lot of things have changed in that short period of time. Everything from the countermeasures that we use, there's a lot more technology involved in our technology with things like sequential lighted chevrons, the methodologies that we use from using hotspot locations to using the highway safety manual and some of the predictive modeling that goes along with that. So there's been a big evolution of how safety has been progressing in recent time. And we put this session together just to talk about some of the things that are happening specifically with the HSIP program, and then also a safety systems approach, which is another relatively new approach to dealing with safety. The group that we have is representation of both PennDOT and Federal Highways Administration. So if you do have questions about what we're seeing or what's changing with safety, in addition to what's covered in the presentation material, certainly feel free to ask that in the Q&A session, and we'll try to answer those as best we can. So with that said, I'd like to introduce our first speaker. Our first speaker is Jason Hershock. He works in PennDOT Central Office in Harrisburg. He's the manager of the Safety Engineering and Risk Management Unit, and he deals with a lot of different things relative to HSIP and low-cost safety improvements. He's involved with several national pooled fund studies through NCHRP and also some of the AASHTO panel discussions on the highway safety manual. So with that, I'd like to introduce Jason Hershock, and he's going to be talking about PennDOT's Highway Safety Improvement Program. Hey, Jason, I think you're double muted. There we go.
Welcome, I'm Jason Hershock. I manage PennDOT's Highway Safety Improvement Program. We recently did a detailed analysis of our Highway Safety Improvement Program and have a lot of good information, and go ahead and share some of that information with you. We'll cover what's in the HSIP, some general crash data, trends from the Commonwealth, and how Pennsylvania has spent our HSIP funds, and how those different projects and different safety countermeasures have performed. The HSIP is federally funded through 23 USC 148, administered by the state with obvious FHWA oversight. Since MAP 21, the state has started to receive more safety funds and is now over $100 million annually due to the FAST Act. HSIP funds can be used on all public roads, used for infrastructure safety improvements, some data and planning, mainly on the infrastructure side, on through data-driven safety analysis. Must also focus on the state's current SHSP, and I will get into the details of that, but if you do have questions about Pennsylvania's strategic highway safety plan, either me or Gavin will be more than welcome, or more than happy to talk to you about those.
Hey, Jason, real quick, we're not seeing your screen.
Oh, all right. Let me get out of that. Should. And How about now?
Yep, we can see it now.
Okay. That's all right. All right. So we just went through that one. All right. Sorry about that. So with the FAST Act, Federal Highway Administration has required us to have some federal performance metrics as to why we're basically to judge a state on its success. Is it working? So each state has these federal performance metrics. There's 5 of them, and I'll show them on the next slide here, which you can now see. First federal assessment was due in 2018 against our 2016 goals. And just overall, Pennsylvania has a 0 death goal by 2046. So here you can see you have 5 metrics, which are 2 based on fatalities, 2 based on serious injuries, and then 1 which is a mix of fatalities and serious injuries specific to non-motorized users of a roadway. So what you can see here is PennDOT didn't achieve any of our targets. We did show progress in the fatality metrics. However, we did not show progress in the ones that involve serious injuries, including the non-motorized. So what ended up happening was we did not meet the federal requirement, and we were required to submit what was called an HSIP implementation plan. The goal was to evaluate our past projects and different policies to determine what the future course of action would be for our program and what was the most effective things that we were doing. We also wanted to identify what was working and continue where we had that success. So this is the cover of what it looked like. It was submitted to the FHWA on June 30th, 2020, 351 pages long. So if you were to print it, about 1.5 inches thick and about 3.5 pounds. So it's better to just look at it electronically. All right, so the plan includes extensive analysis of fatal and serious injuries by jurisdiction, crash types, roadway conditions, and multiple other factors. We reviewed 324 projects that were completed using over $400 million in HSIP funds between 2002 and 2015, including a 3-year review of before and after crash data at those locations. We analyzed noteworthy practices from other states. I'm not going to get into the other states that were noteworthy, as well as what Pennsylvania was already doing that was good. We solicited input from sampling of key stakeholders, MPOs, districts, and some other people, and identified our deficiencies and opportunities for improvement. So just to get into some of the data before I get into what was working, I just want to go over some of these, and they'll present them in an overall state and then a regional by our planning partners, district, and then county. And this is all based on 2014 to 2018 data. So we do have newer data, but the rules that we had to go by were based on these years of data. So here's the statewide. So here you can see just basic fatalities and just serious injuries. So the fatalities sort of hovered basically around that 1,200 to just a little bit below that for the past 5 years when this was being done, but the serious injuries jumped, and we were forced in the FAST Act to change our definition so that a lot of that spike was due to a definition change, which included lesser severities of previous years. So looking at the data here, broke it down into 3 categories, and then there's subcategories of that. But when you look at this, you can see lane departures accounts for 54% of the fatalities and 45% of the suspected serious injuries. You can also see that pedestrians account for about 10% of the serious injuries and 14% of the fatalities. And then up here at the intersections, you'll see about 23% of the fatalities and 32%. Just sort of remember those numbers. I'll show you why. But from this data alone, it would look like lane departures is where we should spend a fair amount of our money. Just another way to look at the data here, just looking at it by crash types and the 5-year average of numbers of crashes, you can see lane departures and crashes that are related to lane departures definitely take up a lot of these top locations. Again, looking at the serious injuries, lane departures is at the top, intersections is now number 2. So looking at it from a regional standpoint, this just shows the fatal and suspected serious injuries with the daily VMT and over 100,000. So just to give a perspective, we're getting just from the crash data alone to based on a volume. And so basically you're looking at crashes to exposure of traffic volumes. This one will show number of licensed drivers in those MPOs and 100,000 licensed drivers. So you can start to see how the fatal and serious injuries are distributed amongst the licensed drivers in those. So we would expect, obviously, DVRPC, the Philadelphia area, to have the highest number of licensed drivers, while a location like Wayne County in rural northern Pennsylvania would have a lot less. And then you can see the distributions there. Then when we go by districts, you can see this just shows the change in fatalities and total injury crashes year by year that were evaluated. So from 2014 to 2018, 2014 won't have anything because there's no percentage change. That was the first year of this evaluation. So you can see in the green where it's decreased and where the white where it's increased. So sometimes it's going up, sometimes it's going down, but mostly it's going down in most of the locations. Again, just another slide of that. And then this just shows not the percentage, but the number of crashes that were either reduced from the previous year or the number of crashes that increased from the previous year. Again, the green is the decrease, the white is the increase. So when you look at districts by their VMT and licensed drivers, in addition just to crashes, you can see there is a lot to pull from. So I had mentioned earlier the HSIP is about data-driven safety analysis. So if we just use crashes, it makes us look one way. If we start to integrate it in with volumes or number of licensed drivers, it starts to shift things and show proportionate values that maybe could be misleading on their own. And so with that, I'm going to show it by county here. Just by total crashes and total fatalities, you can see these are the counties. If we were just to go by total crashes or fatalities, I don't think anybody's surprised to see Allegheny County and Philadelphia at the top for both of these. And then the surrounding metropolitan areas, surrounding counties of those locations also being in the top. So that's what we would expect to see. These next few slides, and I'm sorry, that one's a little bit blurry, but it'll sort of show the difference by just looking at crashes versus crash rate and how that can really skew stuff if we're a state that just bases our funding on those. So on the left side, you can see unrestrained annual frequency of fatal and suspected serious injuries. So by that, it's not surprising. We have it in the metropolitan areas, Philadelphia, Pittsburgh area. It looks like up in the Scranton area there too, down into the Harrisburg capital area. But when we put that based on the 100,000 daily vehicle miles traveled, all of a sudden we see that it shifts from the major metropolitan areas to Forest and Elk counties, which are far from major metropolitan areas. So again, the data can be confusing. Which one should we use? And just to show this again, so single vehicle run off the road crashes, which one's more important? Here, the first one on the left shows metropolitan issues. On the right, it shows our rural northern tier and some of the counties in the middle of the state that are mostly rural. So again, which one do we use? Same thing again when we look at motorcyclists. When we look at just crashes, crash frequency through the observed crash frequency, again, metropolitan areas. But when we do it per 100,000 daily vehicle miles traveled, again, we're getting those rural northern tier counties that pop up to the top. And then running red light, this is one, again, I'm just showing this one because I'm going to reference intersection safety later on, but you can see it's mostly green on both of these. There is the Philadelphia area that's red and there's some like reddish yellow, but when you look at it for 100,000 daily vehicle miles traveled, really not a big issue there. So just keep that one in mind. So with seeing some of those crash trends and some of the data there, just want to go over how we spent our money. So We have spot improvements where you basically just take an intersection or you take a corridor and you do safety improvements. We have the systemic safety improvements where we apply certain countermeasures to combat different types of crashes through known features of a roadway or other risk factors. Over the 2002 to 2015 timeframe, we implemented 324 projects, costed $406 million. All these were basically on state roadways. So it breaks down. Here you can see a majority of the funds were spent on intersection safety. And if you remember the slides before, intersections were only about 23% of the state's fatal crashes, while lane departures only got $94 million over that time frame, but accounts for 54% of the fatal crashes. And then you can see bicycles and pedestrians and then other priorities. So based on the crash data proportions, you can see the spending did not match up with that. What I also want to show there is the cost for the intersection safety and the number of locations that were done. So even while we spent less on lane departures, we were able to cover more sites. And then you can see lane departures compared to the other priorities, about the equal spending amount, but still lane departures was able to cover many more locations. And now we're going to get into these again. So here you can see over 50% of our HSIP spending was spent on intersections. So it wasn't proportionate to where we actually needed to spend the money to reduce these lane departures. So how did these projects perform? I'm going to go ahead and show you on that. So based by year, you can see off to the far right side, the percent change in fatal and suspected serious injuries. Overall, we had 11% reduction, but you can see some years where we actually had increases in crashes. And this is based on before and after analysis. Spot improvements. So how did a spot improvement perform versus systemic improvement? Systemic projects have a much better return. They hit more locations at a lower cost, as this table shows. The cost to reduce one fatal or suspected serious injury crash for spot improvement was almost $8 million compared to a systemic project, which was just under $1 million for the same cost. So again, systemic safety from this evaluation shows it's working, and Pennsylvania has done a fair amount of these. This just shows systemic versus spot through a benefit cost ratio. So you can see the dark green is the best. So here you can see systemic, except for 3 years, outperform spot location quite handily. You have large cost benefit ratios all the way up to almost 15-to-1 with systemic, while the spot locations, the highest there is a 5.4. This is the roadway distribution that we had it spent on. So it looks like rural roadways, we get a lot more return on our investments there. Where you look, if we're spending it on freeways and expressways and interstates, we don't get much of a return at all. And then there was, a very small amount of money spent on the urban local, so it's hard to really draw a conclusion from that. But that location did not have a good return. Again, another urban and rural. Overall, 11% reduction. But there again, this one shows that we have more benefit when these safety improvements are applied at a rural location. This just shows the funding distribution to each MPO and how over that time frame the performance was in each one. So that's basically what it is. This isn't a shot at any region. It just shows how each region's projects performed based on how they were implemented. This is how each district performed. So for the most part, the state was still 11% overall reduction. These are benefit cost ratios for each one of our districts to show where it is. You probably put the king and the queen and the bishops and everything on here and play a pretty good game of chess right there. So I'm not going to go into the details. And then here, finally, I'm going to get into the different types of countermeasures that we use. So this is what worked. These are the ones that we want to keep going to. And it's not surprising to see some of these known and proven, as FHWA would probably have them, as proven countermeasures. You have the rumble strips at the highest benefit cost ratio. So for every dollar we spent on putting rumble strips in, we got a $66.40 return on it. And then you can see it works its way down through. There's just centerline rumble strips in there. We can see the high friction surface treatment, almost a $7 return for every dollar we invested there. So some of the specific locations here, we have an example where centerline rumble strips and edgeline rumble strips were installed. This was a district-wide. This picture here shows a district-wide safety improvement project. The data on the slide considers the high friction surface treatment portion of the work, and it was enormously successful. Every HFST site had some reduction in crashes and overall severities. The site had an existing history of curve-related and wet road crashes, thus justifying the expenditure. This was rumble strip and centerline. Oh, I messed that one. Yeah, that previous one was, okay, there we go. This is the rumble strip one. The previous one was the high friction surface treatment. This one included various locations. So this was a systemic application of rumble strips. The BC ratio was very high for this, but there was also a 14% reduction in single vehicle run off the road and 21% reduction in head-on crashes. So you can see 73.8% total benefit cost ratio. We will take that any day. This was a curve warning, so basically just identifying curves and doing basic signing and delineation. This was through what we call our roadway departure implementation plan. So again, the slide speaks for itself, very successful. And this was systemically applied at multiple locations. So then we know what wasn't effective. Just want to point out, we spent a lot of money on traffic signals and intersection improvements. And when you look at what's the least effective, was the traffic signal modifications, the coordination, the timing, and the replacements, netting actually negative cost benefit results. And so we definitely have done some studies after that to see what could be the cause of that. So quickly, you can see some of these here. This is a district-wide raised pavement marker, the RPMs, not very successful at all. It was performing poorly. The extreme benefit cost ratio was due mostly to the small project and about 8 additional fatalities that occurred after this project was done. Pedestrian bicycle improvement. Just really didn't have a really good performance here. The negative 3.5% or benefit cost ratio is driven largely by a 1%, one extra fatality in this, but there was also an increase in total number of types of crashes. Overall, the project did not increase the motorized user safety in this area. And counter to what you may find in the highway safety manuals where you add turn lanes to accommodate, not always in Pennsylvania do turn lanes work out for us. So in this case, the additional turn lane here did not increase safety. This was an intersection improvement that added the right turn lane and widened the aprons. There was an increase in total crashes after a period that increased the intersection rear ends. Through the angle crashes were reduced. In addition, while the project corridor had over 3 crashes per year, there was less than 1 intersection crash per year. So this is where that data driven comes in. Should this have even been an HSIP funded project? Probably not. Noteworthy practices, and I'll go through these pretty quickly. Pennsylvania's already implemented many different options here, and I'll cover them individually here. So HSIP implementation. PennDOT continues to strive to try to be a leader in implementing the Highway Safety Manual. PennDOT now requires the Highway Safety Manual used in analysis for alternatives and requested for design exceptions. Provided multiple rounds of the Highway Safety Manual training to headquarters and districts. PennDOT's made extensive efforts to fully localize Highway Safety Manual tools. So we have our own SPFs and everything, and we've made tools to make it as easy to use as possible. Data analysis. We started our first network screening in 2017. We're currently in our next round of network screening, which will include a lot more factors in it. It covers all 67 counties with hundreds of locations in most of the counties. And we also have standardized the way HSIP applications come in through a SharePoint website. Innovative countermeasures, you can see on the previous slides of what works. Obviously, we've done a lot of high friction surface treatment, signing, rumble strips, basic intersection improvements. You could see the back plates, the enlarging of the lenses. Those things work, as well as some standards changing, such as safety edge. We've institutionalized different safety processes by updating our publication 638. That would basically involved a big rewrite that happened over about a 3-year period, but that's been done. And many of those things are now finding their way into other manuals, as mentioned before, and resulting in pretty good positive safety benefit. And then intersection safety was also another one. PennDOT's implemented many intersection safety countermeasures at thousands of intersections, ranging from bracketed stop signs with advanced warnings to converting intersections to roundabouts. And also, we mentioned the ICE policy, and Mark, who's going to speak after me, has extensive knowledge of many states who have implemented ICE policies and have reaped the results, rewards of those. So in the end, we encourage that the districts, the planning partners, local municipalities, everybody participating in this, the consultant world, Federal Highway Administration, prioritize highway safety, involve each other more often in the HSIP process. And with that, I'll say thank you, and at this time, turn it back over to Gavin and Mark.
All right, Jason, if you want to stop sharing your screen a while, that way Mark can load up his presentation. We do have 2 questions in the Q&A that we can try to answer live. The first question, Jason, is from Greg Frisbee, and he was asking about the K&A crashes. Are they primarily occurring on state-operated roadways?
Yes, yeah, they are. Most of the fatal and serious injuries are on state highways. Local highways are I think about 16% of our 16 to 20% of our fatalities. So majority of the fatalities occur on the state roadway network.
Okay, and then the next question was from Jason Stimmel. He was asking about I think the slide that you had up about the effective countermeasures. He was asking about the new cable guide rail installations as a countermeasure because he's seen that a lot here in the State College area on US 322 and I-99. So I think you had those listed on your effective countermeasure. I don't know if you want to talk about that a little bit more.
So high tension cable medium barrier, yeah, those were evaluated, and this is the one where it's just systemically applied at multiple locations where you have the risk factors, medians, high speeds, so 55, 60, 65 mile per hour, even 70 mile per hour. What we have found is it basically almost completely eliminates the cross median crashes. We do have increases in property damage only crashes there. Because some of these locations are installed where we haven't had a crash, we do have crashes afterwards, and so you may see an increase in benefit negative in some of these locations. But overall, they have greatly reduced the fatal and serious injury crashes where they have been installed.
And then we have one more question. This was relative to HSIP in local urban. The question was, I believe they saw a slide that said that there was not a good reduction for crashes for HSIP treatments for local urban roadways. Do we know why this may be?
Okay, well, yeah, one, because we only have, I think, maybe 1 or 2 locations. And so if we have 1 or 2 bad locations, that's going to skew it. So we are working on updating our Pub 638 to implement HSIP funds at more local roads through what's a force account option. If Mike Castellano is out there listening, he's going to be leading the effort, our former FHWA guy, to help us get that into policy so we can hit more local roads. So basically why that was so skewed, you had 1 or 2 local road projects that didn't perform well. So while we have the data that shows those didn't work well, I don't think we hope to keep that trend up very long when we can get more local road projects done.
Okay, and that concludes the questions that I have in the pod for Jason, your presentation. So we'll switch over to Mark's presentation.
Thank you, Gavin, and thank you, Jason. Excellent presentation and a great segue, and where Jason was really talking about how we can look at the data differently. I'm going to talk a little bit about how we can look at the safety problem a little differently. So I want to talk about the safe system approach. And again, welcome everybody. I'm Mark Doctor with the Federal Highway Administration's Resource Center, and really delighted to have this opportunity to talk with you this afternoon. So you may have heard about the safe system approach, and if not, that's okay. It's relatively new, but even if you have heard of it, sometimes there's a little misunderstanding about what is it? It's a concept, and sometimes a concept can be hard to describe or to define. So that's what I want to try to do now is give you a good common sense explanation about what the safe system approach is. And just the wording alone can give us some insights. Hopefully we know what safe means, but if we think about the word system, well, the definition of a system is pertinent here. A system can be thought of as a set of things working together, different parts that are interconnected, and that's certainly true with the safe system approach. And a system can also be thought of as a set of principles or procedures according to which something is done. So the two key takeaways here is that when we talk about a safe system, it's really about partnerships and principles. We'll come back to that. Partnerships and principles really is the core of what the safe system approach is. Now, it is an international best practice. The origins of the safe system approach can be traced back to Sweden and the Netherlands back in the 1990s. And it has gone to other countries around the world. Australia, New Zealand, they have had great success with the safe system approach. And I would also call it a change in the way we think about the safety problem. It really is a paradigm shift. And I think ultimately it will result in a change in the way we design and operate our road system. That's the exciting part. Now, I don't have a magical crystal ball. I don't know for sure what those changes might be, but we are learning more and more about what would be consistent with a safe system approach. So probably the best way to define or describe the safe system approach is to go through the 6 principles of the approach. And it starts with a principle that death and serious injuries are unacceptable. And also the related principle that human beings are inevitably going to make mistakes. And on the road, those mistakes can lead to crashes. And when those crashes result, the key is to keep them survivable. And so that ties in with the notion of humans being vulnerable, but also having a tolerance to certain crash forces before harm occurs. The safe system approach is about partnerships and sharing responsibility within the system and building redundancy within the system. And then lastly, being proactive rather than reactive. So the first principle that death and serious injury is unacceptable, I hope everyone can agree with that. It's very consistent with so many of our Vision Zero goals and objectives. But how do we reconcile that with the inevitable fact that human beings will always make mistakes? We will always have mistakes out there, and those mistakes will lead to crashes. Well, this is where I think the first paradigm shift comes into play. When we talk about zero, it's not about zero crashes, it's about zero deaths and serious injuries. That's a big difference. It's not about eliminating crashes, it's about eliminating fatal and serious injuries. So, what is it that separates a crash from being a fatal or a serious injury crash versus one that is minor injury or, better yet, property damage only? Now, this is where the third principle that humans are vulnerable to certain crash forces then kicks in. And another paradigm shift kicks in. When we talk about designing and operating safer roads, that basically becomes an exercise in managing kinetic energy. And you may think back to high school physics and the basic equation for kinetic energy, 1/2 mass times velocity squared. And if you notice that little red dot over the velocity term, that has a meaning in the world of physics. Velocity is a vector. It means it has both a magnitude and a direction, the speed being the magnitude and the direction. For safety, that's the angle of impact between, say, the vehicles involved. And we'll come back to the importance of that in just a second. But also notice that velocity is squared. It's exponential. And what that means is the increase in transferred kinetic energy in a collision goes up exponentially as the speeds go up. And also it is related to the rate at which we are able to wipe off our speed during the braking maneuver. We wipe off most of our speed during the last moments or the last distance of the braking process. That's a real key component. And it's hard to educate the public on this, and not everyone has that knowledge of physics. But it is possible. It is important, and I'd like to play for you a video here. This is a public service announcement video that was created in Australia, and it was part of their Wipe Off 5 campaign. And when they say 5 kilometers per hour, so the campaign is basically trying to get people to drive at 60 kilometers per hour instead of 65. Well, that's about 37 miles per hour as opposed to 40 miles per hour. So more in the urban context. But just imagine the safety benefits if we could get US drivers just to slow down by 5 miles an hour. But here the campaign was for 5 kilometers per hour. So I want to play this short video clip from Australia. And again, the 60 and 65 that they reference are kilometers per hour. But I think this does a great job of trying to put it into common sense terms for the public to understand. So let me play this video here. Hopefully this will kick in well.
What you're about to see will change your mind about speeding. Two identical cars, one travelling at 60, the other at 65. A sudden change in the road ahead, and both drivers first react, and then, a moment later, they brake. And things start to get interesting. Down here, the difference is extraordinary. In the last 5 metres of braking, you wipe off half your speed. So this car is still doing 32 k's when it hits. This one also hits, but only at 5 k's. So no matter how good a driver you are, 5 k's difference up there makes 27 k's difference down here.
Very powerful message that no matter how good of a driver you are, speed makes a big difference. Now, speed management is difficult. There's no way to sugarcoat that. But speed does play a very important part of the safe system approach. And I'll talk more about that coming up. But remember that velocity is a vector. And it's not just the magnitude, but also the direction. Well, thanks to research done in Australia, they've really looked very hard on the effect that the impact angle in a collision has on transferable kinetic energy. And that's what this graph shows. This is from Australia done in, or I'm sorry, from research done in Australia, and looking at the effect of transferred kinetic energy in a collision. And notice that, well, we knew that different speeds, so each of the lines represent different speeds, and obviously a lower speed collision will have less kinetic energy. But look at the effect that angle of impact has. So compared to a 90-degree angle of impact, that would be something like a T-bone collision if someone runs a red light or blows through a stop sign. And if we could get the angle of impact down to about 40 degrees instead of 90 degrees, It has about the same effect of reducing kinetic energy as if the speeds of the vehicles were about 20 miles an hour less. And I'd like to use roundabouts as a great illustration of this point. First of all, roundabouts hopefully slow vehicles down. The approach alignment, the curvature, the splitter island, the deflection that we have, hopefully lowers speeds. We know that roundabouts, compared to basic intersections, have fewer conflict points overall. But even if, let's take the worst case scenario where someone doesn't slow down and someone totally violates the traffic control device. They blow right through the yield sign and they collide with another vehicle in the circulatory roadway of the roundabout. Well, the geometrics of the roundabout would be such that that collision would probably be somewhere between 40 to 50 degrees as opposed to a 90-degree T-bone type of crash. So I think a roundabout illustrates all of those points quite nicely and aligns with that principle of the safe system approach to basically manage kinetic energy, even if people make mistakes and even if they intentionally or unintentionally violate a traffic control device. So the safe system approach, this is probably the best definition that I have seen out there. It does come from an Australian publication, and it describes the safe system as managing the road such that impact energy on the human body is firstly avoided, or secondly, managed at tolerable levels. And we do that by manipulating the speed, the mass, and the crash angles of crashes that occur to change the severity or to change the outcome. So I mentioned earlier that the safe system approach is really about partnerships and principles. And that's where the next principle comes in, that responsibility is shared. We basically have 5 elements that comprise the safe system approach: safe vehicles, safe speeds, safe roads, safe users, and post-crash care. Now, you may recall the 4 E's of safety: engineering, education, enforcement, and emergency medical services. Well, the 4 E's kind of align very nicely with the 5 elements of a safe system approach. And it does begin with safe road users. Now, we certainly hope that users follow the rules, obey the traffic control devices, and that's where education and enforcement can certainly play a role. We hope that users are not distracted or impaired. And again, engineering and enforcement come into play here. But also, as engineers, there's a component where we design and operate the roads with a factor or a consideration for human factors in designing our system so that they're within the tolerance levels of what humans can handle. Then safe vehicles. And there's been a lot of great advancements in vehicle safety technologies. And vehicle safety technologies can be split up into the category of those that help us avoid collisions in the first place, maybe something like lane departure warning systems, and then systems that make crashes survivable. So things like airbags or crumple zones in the vehicle. And with the emerging technologies like connected and automated vehicle technologies, who knows what the future can hold? It's really quite impressive what is possible with safer vehicles. And then safe speeds. And this is where education, enforcement, and engineering, I think, converge all together. And under the safe system approach, we know that there are certain roads that can be engineered to accommodate higher speeds. If you think about perhaps a rural freeway, maybe an interstate, and maybe we put ourselves in a very flat area. So maybe we have to leave Pennsylvania. Maybe we have to go to Kansas or Nebraska. But if you look at the picture here where we have no trees on the roadside, we have very forgiving slopes and a good clear zone and maybe a wide median or a barrier in the center. So there are ways to engineer the roads to accommodate higher speeds and accommodate errors at higher speeds. But we also have a vast majority of our system where those conditions don't exist, where perhaps the roadside is not very forgiving, We don't have clear zones, and we just don't have the factors that accommodate higher speeds. So the safe system approach is not about universally lowering speeds across the entire system. It's really about trying to match the speeds, the operating speeds, to the conditions that are appropriate for the road, the conditions that exist on the road. And that's a key principle, and also one that is important to convey to the public in understanding this idea that not all roads are created equal or are designed to equal levels of safety. And then safe roads, this is where as engineers we really come into play. And safe roads can be designed and operated to try to firstly avoid crashes, and then secondly manage the kinetic energy, or what is transferred to the human body if collisions occur. So avoiding crashes in the first place, that sounds good, right? Well, how can we do that? Well, there are some strategies, especially when speeds are inconsistent. We can try to separate different users in space. This would be things like providing sidewalks for pedestrians or separated bicycle paths for cyclists. Things like protected intersections may fall into this category. If we can't separate users in space, can we separate them in time? Perhaps a pedestrian phase at a signalized intersection, or a leading pedestrian interval, or sometimes just separating conflicting vehicular movements, like maybe protected only left turn phasing at a signalized intersection. Those are examples of separating users in time. And then lastly, trying to increase the awareness or attentiveness of the various user groups. So this can be anything from street lighting to pedestrian enhancements like the rectangular rapid flashing beacon. So all examples of how we try to avoid crashes in the first place. And then when crashes do occur, keeping them survivable by managing speed, managing impact angle, having crash-worthy devices on the roadside, all to manage the kinetic energy transfer. And then the last element is post-crash care. This is where emergency medical response comes into play, but also traffic incident management plays a key role in post-crash care, as does the engineering component of going back and doing investigations of crash sites, just to see if there are any countermeasures that are appropriate to be implemented there. So those are the 5 elements of the safe system approach, and really make up the partnerships. Engineering alone cannot achieve a safe system. It really has to be all 5 elements working together. And that's where the last principles of having redundancy within the system and being proactive rather than reactive come into play. The idea of redundancy, I think, is described well through what many people would call the Swiss cheese model. And if you think of slices of Swiss cheese, that they have holes in them, right? Well, if we think of each of the 5 elements of the safe system to be represented by 5 slices of Swiss cheese. And let's say 5 separate slices, so not one chunk that was just sliced into 5 pieces, but 5 random slices of Swiss cheese. And the holes in the cheese represent the weaknesses in each of the elements. And we know there are weaknesses in each element, but if we can strengthen each element, that can be represented by reducing the size of the hole. And also, when you put the 5 slices together, it'd be rare where the holes line up. And that would basically be representing a failure. And a failure would be when we have a fatal or serious injury collision. So strengthening all the elements and having that redundancy is a key part of it. So it starts with safe road users. And if everyone operated perfectly, if human beings never made mistakes, we probably wouldn't be here today talking about road safety. But we know that isn't true. We know there are holes in that slice of cheese for sure. Well, if a human makes a mistake, well, maybe the safe vehicle can take over, maybe a lane departure warning, or if a crash does occur, the vehicle safety technologies. But we know that safe vehicles aren't fail-proof. And so the next element safe speeds so that if a collision does occur, maybe that collision can at least be survivable if the speeds were low enough. But we know that that's not always the case. There are weaknesses in that element. Safe roads. And if we try to design our roadways to be forgiving, so that, well, in the first place, try to avoid the crash, things like rumble strips, perhaps. And Jason talked about the great cost effectiveness of rumble strips, but having a clear zone to make the crash survivable, all of that is part of the safe roads element. And then the last component, kind of like the last safety net in the safe system, is post-crash care, getting timely and effective emergency response. We know that that golden hour can make all the difference between life and death. And in rural areas, that can certainly be a challenge. Of all the safety issues we have in rural areas, the post-crash care response time is another big factor. But ultimately, our goal is to have these elements work together so that we can return the users back into that group of safe road users instead of just being one more statistic in our crash numbers. And then the last element is being proactive rather than reactive. Oftentimes, when a crash occurs, we go out and we look to see if there are any countermeasures that we can implement. Well, what if we could go back in time before crashes occur, identify the risks, and try to mitigate those risks? Well, that's really the systemic approach to safety. And in Jason's presentation, he talked about the great benefit cost ratios that Pennsylvania is achieving with the proactive systemic approach, and that is fantastic. And other states have seen similar results, and so the systemic approach to safety is definitely consistent with the safe system approach. So I started by talking about the various paradigm shifts that the safe system approach really represents, and it's not a a goal to eliminate crashes, but to eliminate fatalities and serious injuries. And what causes the problem? Oftentimes we try to find some deficiency, something or someone to blame, either the road or the road user. Well, under the safe system approach, we are really talking about overall system failures, which we hope would be very, very rare and allow us to have that goal of virtually eliminating death and serious injury from our roads. And instead of being reactive to safety, being proactive and taking a systemic approach and a data-driven approach. And oftentimes we think about a trade-off, perhaps, between safety and mobility. And we think that they're in conflict with one another. And that's not true. It's not really about balancing mobility with safety, but it's really about ultimately providing safe mobility. That's what the safe system approach provides. So zero is our goal, and a safe system approach is how we think we will get there, because other countries have had great success with the safe system approach. And it's exciting to see the momentum that's building in the United States. So what is next? Well, that's the exciting part, that there's no definite next step. There's no single pathway. That this quote comes from a publication on the safe system approach from the International Transport Forum, and it describes the safe system as a learning by doing process, and that is true. But it is shaped by the guiding principles of the safe system approach. I also began with some definitions, and I want to close with a definition that I think is also applicable here. And you've probably heard the term disruptor. And disruptor usually means a change in the way an industry operates, especially in a new and effective way. And I'm going to argue that the safe system approach can really be a disruptor in how we think about safety in this country, and how we apply it in our design and operational choices. If you think about how we design a road, we often gravitate toward things like a design volume or a design vehicle or the design speed. Well, what if we had a design kinetic energy threshold above which we try to keep the forces of crashes below the point at which harm occurs to the human being. Well, we are getting there, and other countries have had success adopting kinetic energy management models. And so, as a starting point, the Federal Highway Administration is soon going to be releasing our Safe System for Intersections framework and methodology. And it's a first step. It's a first cut at trying to consider the safe system principles and also the kinetic energy principles. And look for this to be coming out early next year, early in 2021. We will have a publication, also a series of webinars to basically describe this framework. And Jason also mentioned the intersection control evaluation process, or ICE. And Pennsylvania, of course, one of the leaders in the ICE policy and process. Well, think of the safe system methodology as a potential additional aspect or consideration that agencies could look at and utilize when they go through, say, an ICE type of evaluation and look at what is the more appropriate intersection control and design form. And so applying the safe system principles to help make those decisions, especially among all of the various intersection forms that we have. So that's an exciting new product that should be coming out in early 2021. So there's a lot of information on the safe system approach. This is just a initial stab at some of the websites that are out there, and a lot of gaining momentum going on. So with that, I think we've got just a few minutes to take some questions. So I'm going to stop sharing and see if we have any questions that have come up. So, Gavin, hopefully we got just a couple minutes.
And Mark, you do have one question. This is from Jennifer Warner. Within safe systems, is there a balance point between forgiving road designs and permissive road designs?
Forgiving road designs and permissive road designs. Interesting question. I guess I'm going to need a little help better understanding what is meant by permissive road designs.
So the example that was given, a road designed to forgive a driver for exceeding the best speeds for a road could unintentionally induce those higher speeds.
Yes. So speed management is certainly a challenge, and one of the aspirations that we're trying to get toward is the notion of a self-explaining road or a self-enforcing type of road, where the design and what the driver or the user sees, what the visual cue of the roadway is, implies an appropriate travel speed so that users select and choose to operate at the speeds that we want. And so the notions of target speed as opposed to, say, a traditional design speed, and a target speed, and designing toward that target, that is work that we're still trying to advance, but that is ultimately the goal. Because you're right, sometimes we may do things unintentionally that induces higher speed. So if you think of a wide open roadway, maybe providing something like a shoulder, it may actually entice higher operating speeds than what is desirable for the context of that facility. So it's a challenge, and we've got a lot to learn, but hopefully our knowledge will continue to evolve, because ultimately we do want to design roads that are intuitive to drivers in terms of what's the appropriate speed, but also have that roadway be forgiving. So it is a challenge, and we're not there yet, but we are getting better. Excellent question. Excellent question.
Okay, we do have one last question for Jason. Jason, this is relative to the proven systemic countermeasures for rural and suburban areas. Are there systemic countermeasures that you are evaluating testing in urban areas, such as measures to manage speed?
Well, okay, I guess that sort of backs off of what Mark just talked about. The only thing I could add is I believe that the traffic calming manual that PennDOT used to have is now going away and is integrated into our design manual. And so there'll probably be some information there about that in traffic calming, but there are proven countermeasures out on FHWA's proven countermeasure website. It depends too where you're integrating heavy pedestrian volumes and all those different things. So I guess it depends. It's probably the best answer I can give for that. But there are going to be some guides. There are some guides coming out. There are already some guides on that. So that's best answer I can give. It probably depends on the situation and who's using that roadway in the urban area.
Okay, well, that concludes all the questions that we had. I think got a little taste of some of the things that are working and some of the things that are different that we're going to be looking towards as we move forward with safety from a department perspective. I want to thank Jason and Mark for their presentations. I think they were pretty informative and some relatively timely information that just got out to people. So appreciate that, and I think we're pretty much right on time for today, concluding here at 12:30. So hope you enjoyed the presentations and enjoy the rest of the conference.